Hello students, this is a continuation of multiplying and factoring. This is a trinomial because it has 1, 2, 3 pieces. Let's see if I can draw a tricycle. Ooh, this is a tricycle. It has 3 wheels. You sit here. There's little handlebars. Okay, 1, 2, 3 pieces. It's a quadratic trinomial because it has a square in the front. And we're going to factor this. So in order to factor, we're going to first build what this looks like. So I'm going to go to my algebra tiles and I'm going to build x squared plus 5x plus 6. X squared plus 5x plus 6. And I'm going to go get those pieces. I'm going to get an x squared piece. I'm going to get 5x pieces, and I'm going to use the copy tool. 1, 2, 3, 4, 5. And then I'm going to get 6 constants, 6 little ones. So again, I think I'll copy those. 1, 2, 3, 4, 5, 6. So now I have built on my algebra tile mat an x squared, 5 x's, and 6. So that's what it looks like. With algebra tiles, that's what x squared plus 5x plus 6 looks like. And you can't put any of those together because if I put these together, I don't magically have 6 squares or 6 cubes or anything like that. So that's what it looks like. If I'm trying to factor it, that actually means I'm trying to write it into a multiplication problem. So what I need to do next after I build it, I'll call this step 1. Okay. What I need to do next is I need to rearrange those pieces as a rectangle. So it's kind of like a puzzle. I want to rearrange until they make a perfect rectangle. So right now, if I put them together, like if I just put them all next to each other, I move them all over, they're not going to build a rectangle. They're going to have some pieces left over. Like even if I put them really close here, it's not going to be a perfect rectangle. Like let's say I put them like that. Uh-oh, this part is not rectangular. There's like a big chunk missing here. Or if I put them over here, there's kind of like a chunk of the rectangle missing down here. So I need to do something different. And what usually we want to focus on is splitting these up. So I'm going to rotate one of them and I'm going to move it over to here. And then let's see if that works. Also, a good thing to know is we put the x squareds up in the upper left-hand corner and the ones usually go diagonal from there. This is where we put our constants. So this is a little closer, but I still have some holes in here. And we just play around with it a little bit. What if I move this one over there? Cool. Yay, I made a perfect rectangle. See, all the pieces fit beautifully together. So that's the next step. First, we get the pieces we have, then we drag them around until we make them fit into a rectangle. And the reason why we're trying to fit them into a rectangle is because the answer to this problem when we factor is going to be the sides of the rectangle. Okay, so step 3 is going to be figure out the sides. Figure out the sides of the rectangle. In order to do that, I could put my horizontal and my vertical frames on here. There, vertical frame here. And I wish I could move the whole thing down. I think I will just grab them all down and move them. Okay, almost there. And the frame is the sort of the outside of this multiplication problem. So I want to know what's going to fit along this side and what's going to fit along this side. And you can see that this one is x. And what's going to fit right here perfectly? Two little guys. Constant of 2. How about the top? What's this? How long is this side? Well, you could see it's x. I'm going to put it out here so you can see it a little bit better. And then 1, 2, 3. All right, so that's what it looks like to have the sides of the rectangle done. From there, we have our answer. We're just going to read it off. So the top of the rectangle, maybe I'll do the side first. The side looked like this. We had an x plus a 2. Okay, so the side was x plus 2. The top of the rectangle was x plus 3. These are 1, 2, 3. Okay, so that's my answer. How do I write the answer? I write the answer as a set of parentheses. So if you factor, you're trying to write a multiplication problem, and the multiplication problem is the quantity of x plus 2 times the quantity of x plus 3. Kind of like a puzzle in a game. Let's look at another one. So here's a different problem. We have x squared plus 5x plus 4. I'm going to tidy up this space, and I'm going to do x squared plus 5x plus 4. Oh, it's a different constant. The last time it was 6, and now it's 4. Okay, so I'm going to build it. X squared plus 5x plus 4. And I have to rearrange these into a rectangle. My x squared plus 5x plus 4. That's what that looks like. And I'm going to rearrange them into a rectangle. This time I'm going to put my horizontal and my vertical in first so that I can kind of see. We always put our x squared in the upper left-hand corner. And then we play around with these. We also put our constant kind of down here. Ooh, 4 is a square number. I can make them into a square. All right. Maybe I'll rotate this one, put some over here, some over here. Let's rotate that. We got 2 missing here. So there's a chunk missing. That's not right. Anyone think they can do it? What do we try here? I'm going to rotate that back. All right. Oh, perfect spot for this one. Yay! I made it into a perfect rectangle. Okay, so I rearranged it until it made a rectangle. This is how you use algebra tiles to factor. Okay, now I need to figure out the answer. And the answer is going to be what 2 things multiply together to give me this as the area. So I'm going to grab x and 1. That fits perfectly along that outside of that rectangle. This is how long this is. It's x plus 1 long. And then along the top, we have x plus 3. Oops, not 3. What is it? X and 4 fit perfectly along the top. Oh, I already kind of know my answer. It's the sides of the box, the sides of my rectangle. So the answer to this problem is x plus 1 along one side, and along the top is x plus 4. So if I ask you to factor x squared plus 5x plus 4, you would break the 5 into 1x and a 4x. So you'd move the 1x down to the bottom. You'd split those two. And then you would see that the answer is quantity x plus 1 times the quantity x plus 4. And if you're really on top of this, you can see that these first 2 had an x and these second 2 had a 4. Okay. We've practiced a little bit of that. Anyway, this is the answer. Let's try another one. X squared minus 6x plus 9. X squared, I'm going to tidy up the space. X squared minus 6x plus 9. All right, let's build it. There's my x squared. And I'm going to get the red ones because it's minus 6x. So I need 1, 2, 3, 4, 5, 6. I'm just hitting this arrow and it's building them next to it. So I've got x squared, 6x, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is what x squared minus 6x plus 9 looks like with algebra tiles. And what's next? What do I do next? Good. I'm going to build them into my rectangle because this is the answer. This is the area, and I want to know the sides of the rectangle. Okay, I'm learning that these go here. And again, I could try to put all these next to it, but these actually are going to go diagonal from the x squared. And you can see I could move them all next to it. We have to rearrange this, excuse me, into a rectangle. That's not going to work. I'm not supposed to put them here. This area is sort of reserved for the x's. All right, that's not a rectangle yet. There's a chunk missing here and a chunk missing here. So I'm going to start rotating these and moving them over there. And I'll move that. It's getting closer. I have 2 chunks missing. Let's move another one over. Now I have an extra. That's no good. So what can I do? What if I make another row with the ones? Do you see it? Starting to come together. Yeah, rotate that. Yay, I did it. That's cool. This one's extra special. Extra special. Why is it extra special? Well, it's a special type of rectangle. So the shape in there is a perfect square shape. Do you see that this is exactly a square? Kind of look down here. We have a little square, don't we? That means that the sides of the rectangle are going to be the same because it's actually the sides of a square. All right, how do I get, so I could see that 3 fit in here, except that somehow when I multiply this 1 times this x, I have to get -1. So the way to do that is to actually flip these over. Because x times -1 becomes -x. So x times -1 is -x. All right, how about the top? Okay, again, you know what? I'm going to grab the -1s from this side because I know this is a positive times a negative gives me. How about the corner? What's -1 times -1? Isn't that +1? Yeah, it is. And then I could copy one more on there. Sweet. Okay, so I have taken my pieces, I've arranged them into a square in this case, and then I found what fit along the outside, which is the sides of the square, which is my answer. So for this problem, I'll show it out with the algebra. We had an x squared minus 6x and 9, and we decided to split up those 6 x's so that they were 3 along one side and 3 along the other side. And then we saw that after we do some math, we have the answer, and that is the side along here is x minus 3, and the side along here is x minus 3. And a really fancy way to write x minus 3 times x minus 3 is x minus 3 squared. Yay! Because it's a perfect square. It's a lovely square. And in the corner, we have a square. We got 9. Isn't 9 a square number? Yeah. And then for those of you who want to push yourselves a little bit, another way to write this problem would be like this. And then we factor out the x minus 3 binomial, and what's left is the x minus 3. All those are good answers. Let's do another one. X squared minus 3x plus 2. X squared minus 3x plus 2. Build it. We got it. I'll put my horizontal on my vertical. X squared minus 3x plus 2. Okay. And now I'm trying to make those fit. So that's what it looks like with algebra tiles. And I'm trying to work this problem backwards. I'm trying to factor it. So I'm looking for the sides of the rectangle that give me this for the answer. So I'm going to put the x squared up in the corner. And this one, I'm starting to see these two have to go down here. And I could either go like that or I could go like that. I think I'll go like that. And then this one I'll rotate and put down in the corner. Yay, I did it. I made it into a rectangle. And then the last thing I need to do is find the sides of the rectangle, because that's my answer. Those are going to be the two things that multiply together to give me that for the answer. Again, this is going to be x minus 1. And then along here is going to be x minus 2. Does it work? If I do x times x, do I get x squared? If I do x times negative 1, do I get negative 1x? If I do x times negative 2, do I get negative 2x? And if I do negative 2 times negative 1, I get my 2. So I did it. Woohoo! Okie dokie, artichoke. All right, then I can write my answer. So for this one, I had x squared. I had 3 red x's because they were negative, and I had a 2. And I decided to put 2 along one side and 1 negative 1 along the other side. And I saw that after I rearranged them, the sides of the rectangle were x minus 1 and x. Oops, I'm going to do it this way. X minus 2 and x minus 1. Okay, that's the answer. Actually, I'm going to do it the other way. We'll do x minus 1 and x. Does it matter? No, because these are numbers that we're multiplying together. And when we multiply numbers together, the order doesn't matter because 2 times 3 and 3 times 2 are the same. All right, x minus 1 along this side, x minus 2. These are the binomials that multiply together to give me this beautiful quadratic trinomial. Ooh, this one's fun. I'll leave that as a challenge. Well, I guess I'll do it. We got 2x squared, 11x plus 10. Wow, 2x squared, that's a lot of pieces, plus 11x plus 10. I like a challenge. Tidy up my space. And I have 2 of these. I have 11 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whew. And I got 10 little guys. I think I'll put them into a rectangle. We'll go. It's fun. Okay, did I get 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Okay, so I have to build these into a rectangle. Let's see if we know that the squareds go in the upper left, and we know that our ones, our ones are going to go down in the corner, and maybe I'll keep them in that rectangle. Let's see if that works. Maybe I'll build the rectangle sideways. Haha. So that's a 2 by 10. All right, so let me put, I was going to move these back down. Trying to build this into a rectangle. I think, no, that didn't work. How am I gonna do this? Oh, did it work? Look how different this is. I think maybe it did work. Nope, it didn't work. So with this kind, there's more possibilities. It takes a little more work to try to figure out how this goes. So what if I put this down here? Can I put these down here? Did I copy the problem right? 2x squared plus 11x plus 10. Can I make 2 more rows? Play around with it. I like a good challenge. Still some pieces missing. What if I do that again? Can I get it to fit? Uh-oh. I still have a piece missing. Okay, I'm back. So this one's actually not working. And that's because when I wrote this problem, I messed it up. So I'm the math teacher. I get to change the problem. And the problem was actually supposed to be this. So it's supposed to be 2x squared plus 10x plus 5. And I got confused when I was building the problem. So now I'm going to change it. Haha, I'm in charge. I can do that. You guys can't change the problem. If it doesn't work, you can write me a note and say, Miss Bliss, this one doesn't seem to be working. All right, I still have 2x squared. I still have 11x, but now I only have 5 to deal with. And really, there's only 1, 2, 3. Oh, these need to go away. Goodbye. There's only one way to make a rectangle out of 5. It's either 1 times 5 or 5 times 1. So I think what I'm going to do for this one is I'm going to go, there's only 2 ways to make a rectangle out of that. So this is the answer I was looking for. Okay, I had 2x squared and 5x and 5, and I made a mistake, but I fixed it by changing the problem. You can see the 2 big x squareds, you can see all 11 x's, and you can see the 5 as the constant. And then what are the sides of this? What are the sides of this rectangle? Well, we had an x. These all have x in common. Okay, these have a 1 in common, and I'm going to copy those straight down. And then along the top, they have an x as a factor. They have another x that matches, and then they have a 1 in common. So there's my answer. I'm going to do 2x and 1 times x, 1, 2, 3, 4, 5. X times 5. And you can always check these. So after you build it and see it, you can actually go back and check and see if it makes sense. If you do x plus 5 and you do 2x plus 1, if you multiply those together, I'm going to do the 2x plus 1 just because we usually put the binomial with the higher leading coefficient in front. Yeah, that's the answer. Those are the sides of my rectangle. So if I ask you to factor this, this is the answer I'm looking for, because this is the sides of the rectangle. And what do I want to say? I want to say that I could check it. Is 2x times x 2x squared? Yep. Is 2x times 5 10x? Yeah. Is x times 1 1x? And is 1 times 5 5? Yeah. So I have all this, and the sides of the rectangle work. All right, so that was a good one. Where's the algebra? This is just multiplying, you guys. And a lot of students can memorize multiplying 12 times 13. You can either memorize your facts or you can have a little trick. But algebra students know that we could build that area model out of that. We could have 12 by 13, and we can visualize that. We know that the area is the answer to a multiplication problem. Okay, and that's an important concept. So that's a really bad 10 by 10. So in math, when we multiply, we can model it with area. All right, be good, work hard, keep learning.